Hey everybody, and welcome to ARE Live. I'm Chris Hopstock, Architect Education Specialist here at Black Spectacles and your host for ARE Live. Today we're going to be joined by guest expert Felipe Guerrero, who's going to be walking through multiple aspects of sustainability and how it impacts different stages of a project. If you think of any questions you'd like to ask Felipe during the Q&A, make sure to post them in the webinar chat. There will also be a page in our ARE community after the episode if you think of more questions after the broadcast. Our next ARE Live will be on May 18th, 2023, where we'll be discussing what you need to know about the A201 general conditions. You can go to go.blackspectacles.com/podcast to sign up. To learn more about the study materials Black Spectacles offers or to watch this episode again later, go to go.blackspectacles.com. Although all of our episodes are available in both video and podcast audio formats after the broadcast, we'll be sharing our screen during today's live, so we recommend watching the webinar to better see how to work through the material. Without further ado, I'd like to welcome today's guest, Felipe Guerrero. Felipe is a licensed architect in New York, my home state, where he does consulting for owners and financial institutions. He was also an instructor at the AIA Center for Architecture in New York and is a Black Spectacles virtual workshop instructor. So welcome, Felipe.
Thank you, Chris. Welcome, everyone, and I'm happy to be here. So without further ado, I'm going to start. Chris is going to do a short introduction, and then we can go with questions.
Yeah, so thanks, Felipe. We're happy to have you. Today, we're going to go through some questions about sustainability that can appear on the PA, PPD, and PDD divisions. Sustainability is a broad topic, and I know it must be frustrating to know what to study in each division. So we're going to be providing some guidance about how sustainability is covered in each of those divisions. We're going to start with PA. Sustainability on the PA exam tends to focus on environmental considerations about the site, and that makes sense. You're in the PA exam, you're planning the project and analyzing the site. You're not quite designing a building just yet. So you're going to see questions about environmental reports and testing, like the first one that we're going to share, and stormwater management, like the second one that we'll talk about. So take it away, Felipe.
All right, so let's begin. So we're going to go ahead and first read the question, and I'm going to point out certain things that I think are important in each of the questions, just so, and this is general for all of the questions in all of the exams, taking keywords and key facts that are given in the question. So an architect is working on a project to convert a 5-story former textile mill building, so that may be relevant, that was built in 1910 into an office space. So again, something important, 1910. The urban infill site is considered a gray field and has been vacant for the past 45 years. Something we identified here, gray field, make sure that we understand what that is. The owner's program includes an interior renovation and facade restoration. Based on the site's history, which of the following should the architect suggest to be included in the project's scope of work? So check the three that apply. This is a type of question that is very common in all of the exams. So the way that I first would approach this question would be to think about some of the information that is given to us, right? First, former textile mill building. So obviously there was some sort of manufacturing. Then 1910, that's a time frame that is going to give us a clue on what type of materials may have been used during that time, before and after that. And then also gray field. So something too important to understand is, if you don't know these terms, of course, familiarize yourself with all of the terms as you're studying. So this is an opportunity for that. Of course, the idea is that you do this before the exam, but in general, any term that you come across in any of the questions that are practiced, my recommendation is always look it up and understand. So in this case, a gray field, the definition that is typically given is that it's an infill or a commercial location where it's an underuse or outdated that is use of the building that is hampering or otherwise not allowing the valuable real estate asset to be what it needs to be. So it typically means that it does have some infrastructure in the building, and it does not mean that there is any implication of pollution. So that's the difference. So something else that you should consider that are similar terms are greenfields, right? In those cases, those are either lands that are previously developed but not polluted, or brownfields would be a land that is previously developed and polluted, likely. All right, so let's go ahead now and go through the question. So of the options that are given, asbestos testing, that may be something that is important. Then phase 1 environmental site assessment, also something to consider. It has to do with environment. So structural load assessment, perhaps this is not related to specifically about the site's history, so it may not be that relevant. Fire suppression system, something that may come into play. PCB testing, so we'll have to, I'll go through in the answers what that entails. PERC testing, also some other type of testing that may be relevant, may or may not be relevant in this case. And then phase 2 environmental site assessment, also known as ESA. So these are the answers that we would expect to have, and I'm going to go through each of them and explain why they are the correct answer, and then the other ones that are not the correct answer, why they are not. So first of all, asbestos testing, that's correct. That's something that should be recommended. And the reason why that is relevant is because think about the time frame, right? 1910. So asbestos has been used throughout construction for thousands of years, at different levels, right? But in this particular case, we're talking about 1910, right? And then based on information that we have from EPA, the asbestos started to be banned, certain elements that had asbestos started to be banned in 1973 or so. So anything before that is a suspect to have asbestos testing. So in that respect, that is something that should be recommended. Then let's go to the next one, phase 1 environmental site assessment. So those ones, by definition, it's an assessment of the likelihood that a site is contaminated, and it's done through visual observations or historical use or reviews or regulations or records, right? It's something that there is, given the fact that this is a former textile mill building, there may or may not have been some elements that may have been contaminated. So phase 1 makes sense to first review the history of the site and determine whether there are possible contaminated elements. The next one, structural load assessment. So that one, it's really not that relevant at this moment, right? There's nothing in the question that indicates that the building is in a bad shape or that there needs to be a structural load assessment done. Some of the information could be analyzed through if there are existing drawings or an observation by a professional. So that one probably is not a good answer. Next one, we have a fire suppression system. So this is important because think about the history of this building. It's 1910, maybe at that time there was or there may not have been a fire suppression system. And even in the case, whenever there's any sort of change or use or rebuilding, that will require and will trigger, from the code point of view, some fire suppression system, especially if it's going to be a brand new renovation, of course, converting from the former textile mill building into an office space, that most likely will require fire suppression system that may not have been in place. So then that's another one that is a correct answer. Then let's talk about PCB testing. So PCB testing could be something that is important, but given the information that we are presented in this scope, in this scenario, that PCB is something that would be implemented in materials that or buildings that were constructed between 1950 and 1979. And again, this is all data that is given by the EPA, Environmental Protection Agency. So given the fact that the years that this is built does not fall within that range, we could say that PCB is not important or may not be irrelevant, right? Had this been done within that time frame, we could suggest that this happens, but that's why it's important always to take into consideration the year in which the structure was built. And then the next one is a PERC testing. And this is important. This is what it means first. PERC testing is not what sometimes maybe, it's not to be confused with a percolation test, right? That's something that would be done to the site itself to find out the rate of absorption of water. So in this case, the PERC testing refers to some contaminants that are mostly found in dry cleaning facilities or metal cleaning, right? Again, given the information that we're given in this scenario, it's textile, but not necessarily a dry cleaning. So because of that, we can assume that this is not the right answer either. And then we go to the next one. So phase 2, environmental site assessment. So let's go by definition. So phase 2, by sequence, it's something that would be done after phase 1, right? A phase 1 would be something that is an investigation that is visual, historical, or given on observations. Phase 2 would be done whenever there is the suspicion based on phase 1 that there may be some contaminated components or contaminated agents in the site. In that case, there would need to be some testing, right? So that's the difference. So in this case, there is no indication that for a phase 2 to happen, there would have to be first the confirmation or the assumption that there are items that are contaminated in phase 1. So for the context of this question, we have already covered that base of initial investigation. So to summarize, the answers are asbestos testing, phase 1 environmental site assessment, and then fire suppression system.
Thanks for going through all those, Felipe. It's really important to know all of these terms when you're taking the PA exam. They can definitely come up on a question like this. And I think when people think of the ARE, they often think of questions about a brand new building, new construction, but I thought it was important with this question to just remind everyone that questions about renovations show up a lot, and this is definitely a type of question that you could see. The last thing I think I'll say about this one is that in terms of sort of the procedure that you go through, one of the reasons that PCB testing and PERC testing are incorrect is that, aside from what Felipe said about them probably not being on this particular site, if that testing was going to be required, the phase 1 ESA would note that they think that maybe these chemicals exist, and then the phase 2 environmental assessment would go further, do the testing and confirm whether they exist, and if they do, in what quantities. So it's important to understand sort of the process that happens at the beginning of a project to figure out all the testing that has to be done. All right, let's talk about stormwater management.
All right, second question. Again, kind of the same procedure. Think about certain keywords in the question that are relevant. I'm gonna highlight them. An architect is working on the subdivision of a large meadow plot of land that will be divided into multiple residential plots. The architect and civil engineer are working together to determine what kinds of systems should be utilized to mitigate the amount of stormwater, right? So that's kind of the main driver here. Stormwater runoff from the site onto adjacent sites, right? So it's purely a site-related question or scenario. There is no talk yet about actual building, so that is important to note here. So based on that, which of the following strategies can be used to mitigate the adverse condition? Check the 4 that apply. All right, so in that respect, let's think about what are the options that are given. Bioretention pond, possibly that is a good option. You know, it's going to be something that may or may not help, we'll see. Septic system. So this one is key to understand that it's something that is not necessarily related to runoff, likely, right? Septic has to do with wastewater, right? Rainwater harvesting, possibility. Swales also is something that we often see related to stormwater management, whether it's the achieving what we need, it's to remains to be seen. Detention basin, perhaps, and then infiltration basin. They're similar. Let's see what they really mean. So The answers are bioretention pond, rainwater harvesting, detention basin, and infiltration basin. And then again, we're going to go through each of these comments and to understand why they are correct and why the other ones are not correct. So bioretention pond, that one is correct. And just by definition of bioretention, it's a technique that is used that uses soils and plants and microbes to treat stormwater before it's infiltrated or discharged, right? So this, what it's going to do is create an area where the runoff water is going to be stay for some time before it's infiltrated infiltrated into the land, right? So it's helping in the sense that it's reducing the amount that it's going at the same time. So it's reducing the speed of the runoff water. Septic system, that one, of course, it's incorrect. Septic systems are for sanitary waste and it's not for stormwater, so it's outside of the scope of what we're talking about here. Rainwater harvesting, that one, of course, is a good option. It's a good possibility. It's correct. And again, by definition, what you do when you're doing rainwater harvesting is collecting runoff water from a structure or from an impervious surface, in this case, a site, in order to store it for later use, right? It could be used later to water some plants or to perhaps purify it and turn it into drinkable water. That's an option as well. So all of that is contributing to not having the water run off into the adjacent sites. Swales, that one is not a correct answer, right? Swales are just a way to collect or redirect water, but they don't necessarily reduce the runoff. They may help direct it to a certain way, but it's not resolving the problem. Then we have detention basins. Those ones are also an option, right? So by definition, detention basins are surfaces that store the water and then provide a controlled flow through the attenuation of stormwater runoff. So these ones are typically thought of as dry ponds, right? They're dry basins. They're not always, you may see them in certain sites. It looks like a pond or a basin. It may have some growth of organic growth in there, but the idea is that it's only really active when the water accumulates and then it detains the water for some time and then lets it seep in. And then we have an infiltration basin, right? That's another type of basin. And this one, it's similar because it's, by definition, it's a shallow artificial pond that is designed to infiltrate stormwater through permeable soils into the groundwater aquifers, right? So it's a similar situation. Again, what it's doing, it's allowing the water to slowly be absorbed by the ground aquifers that are near. So that concludes. These are the answers for this one.
Yeah, thanks, Felipe. And if you haven't noticed, there's kind of a similarity between this question, the structure of this question and the last question, where each of them provide 6 choices that are all kind of vocabulary terms and that you need to know what they mean. But the ARE is not going to ask you a question like that's like, what is a bioretention pond? And then there's 4 choices and one of them is correct. That's a pretty basic recall question. Instead, the ARE will write questions like this, where you need to know not just the definition of one thing, but really 6 things, and then apply that knowledge to a scenario where you're going to make a determination about which one's appropriate based on your knowledge of what those systems do. So just something to keep in mind as you take practice exams, and think about kind of the types of questions and the way they're written, so you can really get familiar with the format of the exam. I also liked this question contrasts with the previous one, where this question is talking about a greenfield site. It was just a grassy meadow at one point, and the last one, the project, the site had a long history of having a building on it. So this site was a greenfield, you could say, even though the question didn't state it, whereas the last question was obviously a gray field. So we are going to move on to PPD now and change it up a little bit. PPD questions about sustainability really differ from PA. You know, in PA, where we're analyzing what environmental or sustainability issues we need to solve for. In PPD, since we're starting to design the building, we're going to address how, based on our findings in PA, we can address some of those things through design, orientation, and sizing of the systems. So with that, take it away, Felipe.
Okay, question number 3. Let's go ahead, get our highlighter. An architect is working on the renovation of a 1950s home. Always take note of the year where anything is mentioned. It may or may not be relevant. Where the client is particularly interested in increasing the energy efficiency of the home. The blower door testing indicated air leakage at a rate of 15 ACH 50. After discussing with the client, the architect and client decide to include air sealing on the facade in the scope of work with the goal of achieving leakage rates of at or below 3 ACH 50. Given the air sealing that will occur, which of the following should the architect also include in the project scope of work? So right out of the bat, what we have to identify and understand is what is the information that they're giving us, understand what it means, right? So what these terms mean are essentially air changes per hour. That's what ACH means, the definition, at a rate of 50 pascals, right? So in this case, we're talking about 15 air changes per hour at 50 pascals or 3 air changes. So conceivably, a lower number is more efficient because it's having less air exchanges. It's going to be more sustainable. So that's what the premise is, going from a very large number to a 5 times smaller, comparatively speaking. And also to note that current codes are targeting this value. So that's why this is relevant. So this is not only helpful in the context of the question, but also to understand that there are certain energy requirements that are given by the code. And in this case, currently it's 3 air changes per hour. So let's go and review what are all of the options that are given. Whole house exhaust, it's something that maybe will not help in this scenario, may or may not help. So let's leave it as one of the options. Double stud exterior walls. Okay, so this is definitely something that will help in the sustainability aspect of the house. However, it's not addressing what we are talking about here, which is air leakage. Makeup air system. So think about makeup air system. So this is something that could be the right answer, right? We're talking about air exchange, and we are reducing the air exchange. So it means that we have to somehow contrast or allow for some air to come into the system, because it's not into the home, because it's not permeating the way that it used to, given the additional control that is given by the new enclosure. Vapor barrier at crawl space, and this may or may not be relevant. So let's go ahead and reveal what are the right answers. So in this case, what we're looking for is makeup air system, right? And again, we're going to go one through all of the answers. So a whole house exhaust, this one actually is incorrect and would not solve the issue of a low air leakage rate, right? So we're trying to go to a low air leakage rate. This is not necessarily going to help in that respect. A double stud exterior wall, again, it may help with the energy efficiency of the house, but it's not through the air leakage necessarily. It may be it has a better R value. It may have other components, but air leakage is not necessarily one of them. And makeup air system, that one is correct, right? We need to include air into the system to account for the lack of air exchange that we're going to have. Conceivably, there's going to be a negative pressure in this house if there's not any air that is being that's not coming into the house. So this could turn into issues where the doors may not be able to be opened as easily, right? Or all sorts of interior air pressure issues. And then vapor barrier crawl space, this one it's not going to address the issue. So again, at this point, the makeup air system is what should be understood as the answer.
Yeah, this question's kind of a fun for me and tricky question, because all four of these things are things that you probably want to include in a project where you're renovating a 1950s home. But the question specifically asks, given the air sealing that will occur, which of these should you specify? So it's really important to read that specific question and understand what's being asked for. This question's really the root of this question is trying to see if you understand that when you seal a home, when it goes from 15 ACH 50 to 3 ACH 50, something's going to happen. There's going to be a lot less air movement, like Felipe was explaining, through the facade of that home, which used to be a pretty leaky home built in the 1950s. You're going to really seal that up. And then when you turn on your kitchen hood or your bathroom exhaust fans, you're going to be exhausting air out of the house, but really no way for new fresh air to get in, and you'll create that it'll create a pressure issue in the home. So I just wanted to point out the importance of really addressing what the question is asking, and not maybe looking at the first answer here and saying, well, whole house exhaust sounds pretty good for sustainability in a 1950s home, so that must be the answer. It's important to read through all of the choices and really pick the right one for the situation. Let's move on to question 4.
Right. Question 4. An architect is working on the design of a small rural conservation center where photovoltaic panels will be used to produce electricity, right? This is something that we see very common now. The client, a local nonprofit organization, wants to also connect to the electrical grid in order to sell any excess energy produced back to the utility company. The architect plans to orient and design the project so that the PV panels will be mounted directly on the roof, which will be south-facing and pitched at the optimal angle for solar collection. So, which of the following components of a photovoltaic system are required? Check the 4 that apply. A few things about this question to put in context, right? The first thing is what this client is trying to achieve is to first produce energy from the photovoltaic panels, but at the same time be able to sell any excess energy produced back to the utility company, right? So that's typically, this is something that is called net metering, right? So just to put a little bit of the question in context, there may be locations or there may be systems that allow this. There may be other systems that do not allow this. So the first thing is to understand, okay, what kind of system are we talking about? It's going to be one that is going to sell excess energy back into the utility company. And the caveat here is that even though this is a perhaps context or location specific question, in the sense that not all locations in the United States, not all states allow for this type of system to be connected, it's important to understand that this concept exists in sustainability, right? So because the exam is not geared to a specific state, there may be states that allow this, there may be states that do not allow this type of system. But in general, the reason why this question is important is to understand the system of how it can operate. And then the other element that is explained here is that it will be south-facing and pitched at the optimal angle for solar collection. So meaning that it's going to be essentially the way that the PV panels are installed, it's going to follow the roof's slope, right? So this gives us an idea that there will not be any kind of special canopy that has to be designed in order for the panels to be oriented in the proper manner, right? If you see some installations, you may have seen installations when there's a flat roof, it does require to have an additional element so that the actual slope of the panels is the proper angle based on the orientation. But in this case, the roof, it's already the proper orientation, so there may not need to have an additional structure. So let's go and review what are the options that are given. An inverter, right? That sounds like it may be something important. A battery, maybe, right? It's important to understand what kind of system this is. So maybe a battery is, or it's not relevant. Mounting legs, somehow these panels have to be mounted. So that could be an answer. Meter for energy produced by the system. This, given the context, it sounds like it would be an appropriate answer. And then PV collector support grid, maybe, maybe not. And meter for energy used by the home. So the answers that we are looking for are based on the understanding of what that diagram would look like, right? So if we understand what is being described in the question, if we have a diagram, it would look something like this, where there's a PV array, right? That energy is going to be sent to an inverter, right? That's one of the answers. And the reason what the inverter is doing is turning the direct current, which is what the output of a PV panel is, into a alternating current, the electricity, which is what the electrical grid uses, right? So that is an important component for sure. So inverter. Then once the energy is transformed from DC to AC, right? Always think about AC/DC. That's always an important concept when we're talking about electricity. There's going to be meters, right? So whatever energy is produced is going to be metered, right? We have to know how much energy is produced. So this one right here will be a meter for the energy produced by the system. And then this one is going to be a meter that is going to measure the energy that is used by the house. And then in between there's going to be a connection so that the energy that is produced can be sold to the grid. So given this diagram and what we've talked about, the correct answers are this one. So again, inverter, we talked about it. The output of a PV panel system is DC, direct current. So it needs to be turned into alternating current in order for it to be used by the grid and transferred through the grid. A battery, so conceivably, that is something that could be used in a PV panel system. However, in this particular context, because it's going to be sold back to the utility company, then a battery is not necessary. It could be, but it's not necessary. It could be used. There are certainly systems that operate this manner, but the way that this context, the way that the question is presented, it's not necessary. Always think about required, right? So this one, it's not required. Mounting legs, of course, there's got to be some way to attach these PV panel systems into the slope of the roof. So this one is one important component. Meter for energy production system, meter for energy produced by the system, as we discussed. In order to quantify the amount of power that is sold back to the utility company, there's got to be a meter. PV collector support grid. So this one, it's not part of this type of system. So this is not one of the options. And then lastly, meter for energy used by home, right? So essentially, we have to basically what is sold back to the utility company is the difference between the meter energy that is produced by the system and what is used by the home. So that difference is what's going to go back and be sold to the utility company. So it's really a mathematical process to understand the difference. So those two meters are important for this type of system.
Thanks, Felipe. So before we move on to PDD, I just want to summarize the last two questions that we talked about. So the previous one, we were describing what needed to happen to this house that was going to receive some air sealing, what the architect needed to include in the design. If that question was written during the PA stage, the question could have said something like you're meeting with your client for the first time, determining the scope, and you both determine that you're going to be air sealing this home. So what type of a test would you need to do to figure out how much air sealing is needed? And the answer to that would be a blower door test. That's how those that ACH 15 number was probably developed in that scenario. So then in PPD, you're determining what components need to be part of the system to make all of that work. And then another question about that scenario in PDD might be about specifically arranging and orienting that makeup air system and sizing it maybe so that it works given the air sealing that you're doing. So that's a good example of a breakdown of these 3 exams and how each of them can kind of cover the same project and the same part of a design, but in different ways because they're really about different phases of the project. Same with this question about photovoltaic panels. In PA, you probably would be talking to the owner about their goals for the solar system that they want to install and understanding those goals. PPD are going to be determining what components of the system are needed, just like we did in question 4 here. In PPD, sorry, and in PDD, you might be arranging the components of that system so that it works properly and is integrated with the architecture of the project. So we will move on to PDD now. Just like I said, PDD questions around sustainability really get into the details that you're expected to produce during the construction documents phase. You might be finalizing material selections to meet certain sustainability criteria. In doing so, you might be considering the embodied energy or embodied carbon of those finished materials, and you'll probably be calculating values of wall assemblies for permit documentation. So our 2 questions that we're going to go over revolve around those 2 topics.
Okay, question number 5. An architect is working on a new construction office building where the client is interested in pursuing a sustainability certification. The 2 are discussing materials to use in order to reduce the project's total embodied carbon. What factors affect an individual's material embodied carbon? Check the 4 that apply. So the very first thing that we have to understand in this question is what does embodied carbon mean, right? And that's going to help us determine the right answers. So just by definition, embodied carbon refers to the total impact of greenhouse gas emitted for a material extraction through the end of its useful life, right? Pretty straightforward. And something that it's also by definition, it indicates that the embodied carbon is calculated by summing all of the greenhouse gas emitted from non-renewable energy sources resulting from sourcing the raw materials, right, from the very beginning, manufacturing, transporting, construction, and installation activities, as well as ongoing material product energy use, maintenance, repair, and finally, disposal. So it's a really long life cycle of the material. And also important to understand is that this greenhouse gas are presented as carbon dioxide equivalents. And then it's a calculation. There are many ways to calculate a specific number that is given to each part of the phases in the life cycle of materials. And also very important to understand in this context is the difference between embodied carbon and embodied energy, right? Years ago, there was a push for thinking about embodied energy, but more recently, the focus has been on embodied carbon. And the reason is that embodied carbon is a more accurate way of understanding what is the impact of any type of material as it relates to greenhouse gas emissions, right? Embodied energy was only partially describing that because there could be instances where a material is being manufactured through the use of a renewable source that does not have any kind of carbon footprint. So that wasn't a very accurate way of talking about the impact on the environment. So that's why more recently the emphasis has been on embodied carbon. All right, that being said, the answers based on the description and based on the definition are distance from source of material to project, techniques used to install material, method of extracting raw material, and technique for disposing of the material. So let's go and explain one by one why are these relevant. So the first distance from the source of the project, that one is correct. Think about what is the energy or the emissions that are produced by transporting the material, right? It's going to go on a truck. Whatever is being produced is going to go in a truck. The trucks are going to be using gas. It's going to be producing greenhouse gases. So that's why that is one of the right answers. Amount of time required to produce the material, that one is incorrect. It's not directly related to embodied carbon, right? Techniques used to install the material, that one is relevant. Think about, for example, the combustion in a torch applied roof, right? There is some energy through, there's combustion, there's green gas produced through this method. So that's why it is one of the important items to think about. Then method of extracting raw material. Again, this one is correct. It's by definition, think about the amount of energy that is needed to obtain aluminum, for example, right? It's going to be a lot of energy that is potentially from combustion. Amount use of the project, maybe, but it's not as important, it's not as relevant in the carbon discussion, in the embodied carbon. And then lastly, technique for disposing materials. Correct, this is something that it can be very impactful. Think about combustion to melt metal, for example, right? There's going to be a lot of gas that is produced in this process.
Thanks, Felipe. Yeah, I just wanted to talk a little bit about this question, how it's put together. This is probably the most straightforward in today's presentation. It's almost a definition question, but it's not just asking you what is the definition of embodied carbon. It's taking that a step further and asking you what considerations go into considering a material's level of embodied carbon. So not every question on the ARE will be around a specific situation. I would say most of them are, but there are some questions like this where you'll simply need to know about a term and really what goes into it to be able to answer it. So let's take it home with question 6.
Right. So question 6, refer to the exhibit. We'll show it in a little bit. An architect is designing a new multifamily residential project where the primary structural system will be dimensional lumber. The project is located in climate zone 3, so that's going to be relevant. The architect's office has a standard chart of insulation values. So they're telling us they're going to be using fiberglass bed insulation, R3.5 per inch, and then extruded polystyrene R5 per inch. Excluding wall finish and sheeting, which of the following wall assemblies meet the project's requirements and creates the thinnest possible wall assembly? So wall A is going to be fiberglass bed insulation with 2x4 studs with 2 inches of extruded polystyrene at the exterior. Wall B, fiberglass bed insulation with 2x6 studs with 1 inch of extruded polystyrene at the exterior. And then wall C, fiberglass bed insulation with a double stud wall that is 8 inches total thickness. All right, so given this, let's review what are the exhibits that are given. So remember, we talked about 3, and then it's going to be a wood stock construction. So one of the important key elements is to identify and be able to navigate this chart. First of all, we are here, climate zone 3. We're here in the group R, and then we're gonna go all the way down to where it says wood frame and other. So these are the values that are the target for this example, right? It's gonna be through, and by the way, of course, this is taken from the code from ICC. It's taken from, it's applicable to each jurisdiction will have their own version of a chart like this. So R13 plus R3.8 CI. So always important to understand continuous insulation, or alternatively, a wall construction that is R20, right? So first right out of the bat, to understand that there are options to achieve this criteria that we're giving, and it's all based on a prescriptive method, right? There may be alternative ways to achieve what the code requires, but in this particular case, we're talking about a prescriptive method. So let's go and evaluate what it's given. So we talked about wall A. It's a nominal 2x4, but the actual dimension of the studs is 3.5. So that's what it's going to send to give us what is the amount of insulation that will fit within the cavity. It's going to be at a rate of 3.5 per inch. So that gives us a total of 12.25. Now, if we go back to our requirement, we need to have R13 plus R3.8 continuing insulation. So in this particular case, because this wall does not meet that criteria, right? This is less than 13, so then that wall is not acceptable. Somebody could argue, okay, it's R12.25 plus 2 inches of R5 per inch, which is 10. That's a total of 22, which is larger than R20. However, the math of this, the way that this R values are calculated, it's not a one-to-one, right? The thought process is that when you have a cavity insulation, you're still not insulating the 100% of the cavity. There's going to be studs that are interrupting that insulation, so that has to be accounted for. So that's why they give you the option to R13 plus R3.8 continuous insulation, or R20. So that's important to make that distinction. In any case, just for consistency, that wall assembly would be 5.5 inches, but we've already discarded because it does not meet the criteria. Wall B, we have 2x6, which the actual dimension is 5.5 times R3.5 per inch. That gives us an R of 1925, which meets the minimum of R13. And then 1 inch of the insulation that has R5 per inch, so that's another 5. So it does meet both criteria, right? It meets the R value and the continuing insulation R value. So that one, and that one has a dimension of 6.5. And then lastly, wall C, it's 8 inches of R 3.5 per inch. So that bad insulation has that value, so it's going to be an R28. So this obviously has a better value than wall B. However, it's 8 inches. So if we go back to what we were looking for in this answer was to find which is, and then we'll go to the next, find which is the assembly that meets the project requirements and creates the thinnest possible wall assembly. So in this case, the answer is wall B, right? It's 6.5 and meets the criteria of the chart.
Thanks, Felipe. We are done with our questions, so we're going to move on to Q&A. Quickly, somebody asked where this chart came from. It's from the International Energy Conservation Code, IECC, and I think it's in Chapter 4, but it's definitely in the IECC, which is referenced by the IBC, so you can find it there. Felipe, if you could go back to the question about embodied carbon. Somebody asked, why doesn't the amount of carbon or steel on the project affect the embodied carbon?
Talking about the amount used within the project?
Correct, yeah, choice 5.
All right, so what we're talking about here is the actual material, that the life of the material, not the material and its use or how much material is used in the project. Does that make sense? So here we're specifically asking about the choice of material.
Yeah, exactly. I think the key words in the question itself are what factors affect an individual material's embodied carbon. So the amount used within the project obviously affects how much embodied carbon is in the project. If you have a very large concrete building, it's going to have a lot more embodied carbon than a building that just uses concrete for the foundations. But it's really important to answer the specific question that's being asked, which for this example is asking about an individual material's embodied carbon. We'll just go in reverse order here, I guess, up to question 4. We had one question about when might you need a battery in a photovoltaic system?
All right, so that's is one of the options. Again, think about photovoltaic systems come in many different flavors. One of them could be one in which it's not connected at all to the grid. So essentially, you have your PV panel, any of the energy that is produced is stored in a battery, and then from the battery, that's how you use it, right? So it's something where instead of selling back to the utility, you harvest or you save that energy and then use it at a different time. So that's the difference. I believe if you think about Tesla came out with one of systems that works like that, right? They have their own, I wouldn't say it's PV panels. I think they talk about more of solar shingles or something to that extent. So the intent of that system, if I understand, if my understanding is that it's meant for it to be self-sufficient, not connected, go off the grid, so to speak. So that's when a battery would be relevant.
Yeah, I think you could definitely add a battery to this type of a system if you wanted. But again, since the question only lets you pick 4 things, there are 4 answer choices here that are definitely required based on what you're trying to do, have PV panels and use some of the energy and sell some of it back to the grid. Therefore, you have to pick the 4 that are really necessary and required, like Felipe just highlighted, to answer this specific question. One more on this one. Someone's asking, actually 2 people asked, why do you need the mounting legs and not the support grid? And the other question, which is very similar, was saying that the question states that PV panels will be mounted directly on the roof. So why do you need legs?
Right. So what it means by directly on the roof means that there's not going to be a canopy. As I explained, if you have a flat surface, you have to provide an additional support, right, for the panels to be oriented in the proper angle. In this case, we're talking about mounting them directly on the roof. Literally, I mean, the literal translation would be directly. However, you do need to attach them, right? So there's got to be some way to attach them. They're not just going to be laying, with just put up there without any kind of support. So mounting legs, that is a common way of attaching them. So essentially, it's just going to be some item that is attached to the surface of the roof, to the structure, and then the panel is mounted on that. But in this case, the assumption is that the angle is derived from the angle of the roof, which is matching. So, and then
Exactly.
PV collector support grid, that's one of the other, a support grid. That's exactly what a system that does not have its own angle derived from the roof is, right? You have to support grid, you have to build it up and then tilt it to the right angle. So
yeah, those support grids in my experience are typically used for ground mounted solar where you have a big open field and you want to put solar panels there. Obviously the ground is relatively flat and you need some sort of a support system to tilt them. You could also use those types of support grids on a flat roof system where obviously you don't want the PV panels laying flat on a roof. That's not the optimal angle. But as Felipe said, the mounting legs are a really critical part of a PV system when you're installing quote unquote directly to a roof. They allow the roof to operate properly. If you literally screw down a huge PV system to a roof just directly onto the roof, you would affect the way the roof drains. You would also probably overheat the solar panels because they can't get any air circulation under them. So they are typically mounted, when we talk about directly on the roof, they're typically a few inches raised off the roof. That allows for air circulation and water drainage beneath them. Let's see, moving up to, I think it's question 3. Could you give us an example of a makeup air system, or maybe just describe a little bit more, Felipe, how that type of a system works?
So yeah, essentially a makeup system is, think of it as a fan that is introducing, oh, let me go back to the question, that is introducing air into the space. For example, in multifamily projects, and this is by code, you have 2 options. You could either provide makeup system by natural ventilation, so that means that you have to have windows open to a certain point, or some of the air comes into the apartments through the threshold, or you provide makeup air, which is you're going to have a fan that goes all the way to the roof and it's going to pull air into the unit so that there is air. So that, that's that example, I'm giving it as multifamily because that's when it's most commonly used. But the same concept applies to a single home, which is this case, right? You have to provide some air. So essentially it's a fan that is introducing air into the system to equalize the pressure, right?
Perfect. You could also pre-treat that air if you think about it in a cold climate. If you're installing this makeup air system and it's 20 degrees outside, you're without doing anything to that air, you're going to be introducing 20-degree air into the house, which is not ideal, and it just increases the heating load of the house. So what's often done with these makeup air systems is they have convective coil in them, which pre-treats the air, raises it up to a more acceptable temperature that's comfortable. And if you want to take that to the extreme, you can use the heat that would be expelled up the boiler flue and otherwise wasted. You can sort of harness that heat and use that to heat this coil in the makeup air system and really have a relatively close to net zero home. That's a common net zero strategy. Moving up to question 2, we've got a couple of questions wondering about why swales are not the correct answer here. One person saying, wouldn't they mitigate the amount of water, and another person saying that they're almost the same as infiltration basins. Why is infiltration basin an answer and swale not?
All right, so swales, what they're doing is, think about it in a topography, it's the area that is low, it's the valley. So what it's doing, it's directing the water to a certain location, but it's not always necessarily having it infiltrate, right? Its main purpose of the swale is really to direct the water to a certain location. While the other ones that we've discussed, they're sort of a basin, right? We talked about basins. They're allowing the water to be absorbed by the soil or whatever green material is being proposed in those cases.
Yeah, I would say most of these systems would incorporate some sort of swale to get the water from where it is to the system, but the swale itself doesn't necessarily mitigate the problem. If you just have swales with none of these basins or ponds or the rainwater harvesting, you'll just be directing that large amount of stormwater somewhere else where it will be a problem there. And you certainly can't use a swale and just direct the stormwater off the site. That would be adding a lot of excess stormwater to your neighbor's property, which you cannot do. So swales are part of many stormwater management systems, but they don't directly mitigate the amount of stormwater that's going off the site. They just direct it to a certain area where you want to eventually deal with it. So up to question 1, we had a few questions about this, all centered around why a structural load assessment is not part of the answer. Felipe, why don't you explain that again? And then somebody wrote in specifically about an NCARB question that's similar to this, and I want to explain why this question is different from that one after.
All right, so given the information, there is no indication that a structural load is necessary, right? There is no indication that there was a issue with the structure. Furthermore, think about manufacturing will probably have a higher load than office space. And that's one part. And the other part is a structural load assessment is really done in circumstances, for example, when you want to test the ground, right? Or if there is information that is missing and you don't know what the loads of the building, the design loads are, that could be, but there's assumptions that you can make based on if there is no specific documentation, there are assumptions that can be made. And if those assumptions are not, if there's not confidence in those assumptions, there are other ways before going through a structural assessment, load assessment, right? It's kind of the same principle as phase 1 and phase 2 environmental site assessment. In that sense, the first thing that you probably would do would be to understand what is provided by documentation, observations, and then if that leads you to believe that there may be an issue, then perhaps you would go through a structural load assessment. So that's kind of a last resource in the order of the things that should be done in a space and in a building like this. But furthermore, as I mentioned before, there is no indication that there are any issues. It doesn't say that it's been, there's no observation, there's deflection. Even deflection is not necessarily an issue. It's a known fact that throughout the years, for example, reinforced concrete will have a certain deflection that is acceptable, and it doesn't pose any structural issues. So I think those are the reasons. Now, the other thing is, it's not impossible or it's not completely out of the question that a structural load assessment should be done. If there are reasons to do such a study, then it is, but nothing in this question and given in the scenario suggests that that is a concern. So I think that's the best way to think about this. And then also, and this applies to all of the questions, at some point when you're answering a question, all of the answers may be correct to a certain extent, but your role is to rank those questions and make sure that you're choosing which are the best answers, right? And that's often the challenge in these exams.
I think that's a really key takeaway. I think when looking at this question, and you can easily say that, well, I want to cover my bases here and I don't want to take on any liability, so I'm going to suggest every and any test that I could possibly think of before I start designing this project, and that's certainly one approach. But on the ARE, the question says you have to pick 3, so we have to pick the best 3 in this scenario. I think that what Felipe started with was really strong, because saying that this is a 5-story formal textile mill from 1910 is, if you're familiar with sort of factory buildings from the turn of the century, they're extremely robust structures. We're not adding on to that structure at all. We're doing an interior renovation, and based on that, we're converting it to offices. We're not going to be increasing the load. It was designed to have these massive textile milling machines in it. So we're going to put some cubicles and some people. It's probably going to be a lot lighter load than the building was designed for. Now, somebody wrote in saying that this is similar to an NCARB question. I found that question and I'm familiar with it. It's on NCARB's PA exam, question 11. That question is talking about an owner hiring an architect for a feasibility study for a new 3-story apartment building above an existing cast-in-place concrete garage? And the answer to that is that your first step should be to hire a structural engineer. That's super different from this question. If you're adding anything on top of an existing building, even if you were adding on top of this existing building, I would say that structural load assessment and having a structural engineer engaged early is extremely important. So I just wanted to point out the difference between this question and that one, and sort of a caveat that when you're answering any practice exam questions, whether it's ours or the NCARB ones, I wouldn't have as a takeaway from that question that you should do a structural load assessment early on in any project. It's there, like I said, sort of in the beginning of this podcast, is that each question really presents a situation and you need to respond to that individual situation. So that is it for today. And just a reminder that our next ARE Live will be on May 18th, and we'll be talking about navigating the A201. You can go to go.blackspectacles.com/podcast to sign up, or check out the community page for this episode. Finally, please stick around for a few minutes after the broadcast to take our survey and share any suggestions you may have for future episodes of ARE Live. We read them all, and we use your feedback to make this podcast as helpful as it can be. Thanks for watching.